Hey guys, I'm Jed. Welcome back to my LeetCode review one-take vlog on the 17th problem. Letter combinations of a phone number. We are given a string containing digits from 2 to 9 inclusive. We will return all possible letter combinations that the number could represent. We could return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. We need to note that 1 does not map to any letters. 2 maps to ABC, 3 maps to DEF, and so on. Then, let's see the example 1 here. We got inputted digits 2 and 3, and our output is the letters from 2 and 3. We need to generate all the combinations like AD, AE, AF, and so on. Next, let's get into the intuition of this problem. So we have a string of digits from 2 to 9, and each digit maps to several letters on the phone keypad. We need to find all possible letter combinations. This is clearly a combination problem where we need to consider all possible choices at each position. So we could think of 3 approaches. The first approach is backchecking with depth first search. We could build combinations 1 character each time. For each digit, we'll check all possible letters and recursively build the rest of the combinations. And the second approach is breadth first search. We could start with empty string and build up combinations level by level. And the final approach is iterative approach. This approach is similar to breadth first search approach, but using a queue. Alright, let's start with the first approach, backchecking with depth first search. At the beginning of the code, we'll create several variables to help us solve the problem. So the first variable is private. The type of it is map of character to string. Let's call it digit to letters. Gets a new empty hash map. Then we'll create another member variable, private list of string. Oops. This variable is named result. Gets a new empty array list. Alright, let's get into the method body of letter combinations approach. First, we'll check if the input is valid. And code is if digits equals now or digits dot length equals 0. Then we just return the empty array list because there is no combinations. Then we'll initialize our digit to letters mapping according to the phone keypad. And the code is digit to letters map the output of character 2 maps to ABC. And let's copy this line of code. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. 3, 4, 5, 6, 7. Oops, 7, 8, 9. Three maps to DF, 4 maps to GHI, 5 maps to JKL, 6 maps to MNO, 7 maps to PQRS, 8 maps to TUV, 9 maps to WXYZ. Oops. Alright, then we'll call our backchecking method with an empty current combination and the starting index at 0. And we'll implement the backcheck method at the following code. Let's call it the first backcheck method with 3 variables. The first variable is the digits. The second variable is the start index at 0. And the final parameter is a new empty string builder. Finally, after the backchecking, we'll return the result list. Okay, let's get into the implementation of the backcheck method. Let's declare this method private void backcheck with 3 parameters. The first parameter is string digits. The second parameter is integer index. And the third parameter is string builder called current. Then we'll check if index equals to digits.length. If so, which means we've found a valid combinations, and we'll return if index equals digits.length. Oops. Then we'll add it into the result list current.toString, and we'll return this method. Next, we'll get the current digit we are processing. Character digit gets digits.character id index. After that, we'll get all possible letters for this digit. String letters gets digit to letters dot get off digit. Then we'll check all possible letters for the current digit by using our for loop. Integer I starting at 0 when I is less than letters.length. We'll increment I after each iteration. For each iteration, we'll add the current letter to our combination. Current.append of letters.character I. Oops. Then we'll recursively build combinations for the next digit. Backcheck of digits index plus 1 and current string builder. Next, we'll backcheck by removing the last letter so we can check the next letter. Current dot delete character at current dot length -1. Alright, that's all of the code. Let's submit our code and check if the solution passes all the test cases. Bravo! Our code got accepted. Now, let's analyze the time and space complexity analysis. So, for the time complexity, it is big O of 4 to the power of n times n, where n is the number of digits in the input, and the time complexity is made of 3 factors. The first factor is each digit can map to at most 4 letters, such as digit 7 maps to PQRS and digit 9 maps to WXYZ. The second factor is we have n digits, so we have 4 to the power of n possible combinations. And the third factor is for each combination, we spend big O of n time to build the string or the string builder. And the space complexity is big O of n plus 2 to the power of n times n, because we have stored all the possible stack for the depth first search, and we build all the possible combinations in the result list. Alright, this is the end of my LeetCode review vlog on the 17th problem, and I highly recommend you guys to visit my online GitHub page on this URL. You can see all the problems with very detailed initial intuition, solutions with code and explanation, and the final time and space analysis. You could also visit my GitHub repository here, which contains all the codes and notes to build this online GitHub page. And I'll put those 2 links on my YouTube description below. Thank you guys for watching, and I'll see you next time. Bye bye!